Hey everyone, it's Sahil. Welcome to my YouTube channel. So in this video, we are going to create a bank using Solidity programming language. So this will be a first video in a series of video where I will be creating different Web3 application, either creating different Web3 application or extending the application that we will build in this video. And for this video, I have collaborated with Questbook. So let me show you what Questbook is. Questbook is a decentralized university. They have detailed everything that they are doing and whatever they are planning to do and their grand vision on their blog. And I won't go into much detail in this video because it will take a whole video to explain everything. But that's a brief introduction of Questbook. So they are doing many awesome things, but for this video, we are concerned with the courses that they are providing. So for this series, I will be mostly going through building on Ethereum course, and let's go into building on Ethereum course. They have this different tutorials or quest as they call them. So there are in total 5 quests in building on Ethereum course. And so I was going through this course myself, and it's all written content, so there are no videos. So while I was going through this content, I was like, as I earlier described in my video, that I'm going to document everything that I will be learning in my blockchain development learning journey. So I thought that if I'm going through this quest, why not convert them into video, so that I can share my journey with you, as well as, you will get this content in the form of video. So I plan to create videos, and I reached out to Questbook and I told them about my idea that, hey, this is what I'm planning to do. I'm documenting my journey and I'm planning to create videos. And they were like, it's a crazy idea. And they were like, we were planning to do something like that as well. So I was like, okay, then let me do it. So, well, they are not sponsoring this series yet, but this is just me documenting my journey and converting this quest into video format, right? And there's one more thing about this quest, that when you complete all this quests, so suppose you complete all of this 5 quests, you can earn in cryptocurrency, and you can also earn an NFT as well. I think this is just for first 100 people to complete this course or something. So that's that. And yeah, with that out of the way, let's get into the code. So in this first quest, we'll be creating a bank using Solidity and Ethereum, where a user can deposit money and earn real interest. And as the quest goes on, you will quickly realize that how easy it is to develop application that involve real money using Ethereum and Solidity, unlike any of the programming languages that you might have interacted with. Ethereum is basically a blockchain, underlying blockchain infrastructure, and Solidity is the language. By the end of this quest, you will be able to create smart contracts, which are basically programs or application that are as good as Compound and Pull Together, which are multi-billion-dollar projects. So for programming in Solidity, we'll be using this online IDE called Remix, which is provided by the Ethereum Foundation itself. It's kind of slow, but we don't have to spin up our own development environment, and we get everything to develop and create our first contract right from the browser itself, because there are a lot of things that you would need to set up if you were to create smart contracts locally. So let's analyze the first smart contract that they have provided in the third subquest. So let's open up the link. It's this one. I guess. No, it's this one. Is it? Yeah, it's this one. So you will notice this line pragma solidity, which basically mentions the version of the language that we will be using. I mean, see, other languages encourage the use of versions, but it is required in Solidity because the development of Solidity happens very rapidly and new versions come out like every next week. So, and it breaks the earlier functions and so on. So in each of your smart contracts you need to mention the compiler version that you will be using. All right, so after that we have this keyword contract. So this contract keyword is similar to class keyword that you would find in other languages like Java. So you can say that this is basically a class. A contract is basically a class. But what is different in Solidity is that every contract has its own account, and you can send money to this account, and this contract can even store money. Each program or user has an account, and each account is identified by an identifier called address. So address is like this. It's basically a hex string. Okay, and once we send the money to this contract, the contract can do anything it would like to do with that money. It can even transfer the money to other contract. It can transfer the money back to another user. It can just hold that money and sit on it and do nothing, or it can even burn that money. So it depends upon the logic that you write in the contract. As the quest progresses, you will see how we can write a logic to get money into this contract, and how we can use those funds to create our smart bank. Solidity is a compiled language, so let's see how we can compile this smart contract that we have created. You can click on this button and it will take you to the compiler section, and let's select the latest version 0.8.7. so we have mentioned that the version should be between 0.7.0 and less than 0.9.0. okay, so let's click on this button to compile our contract. Okay, so it has been compiled, and you might get this warnings, but you can ignore those warnings for now. But if you hover over to this symbol, it will say that compilation finished successful with warnings. Okay, so let's head over to the deployment section. You will notice that we have this account section, and in the account section Remix provides, I think there are in total 20 accounts, each with 100 ether. So ether is the cryptocurrency which is native to Ethereum blockchain. Now this ether that you see right now, this 100 ether in each of this account, are not real ether on the Ethereum blockchain. They are the test ether that Remix provides for testing our smart contracts. And to deploy the smart contract on the blockchain, it costs some ether. So let's click on the deploy button. So as you can see, the contract has been deployed. Now, because we are in the testing environment of Remix, the contract got deployed quickly, but while deploying it to the main Ethereum blockchain, it will take some time. But we don't need to worry about that right now. And as you can observe that some amount of ether has been deducted from this first account, because it costs money or ether to deploy our contract, as I already told you. And as this first account was selected by default, the ether got deducted from this account. So now that the contract has been deployed, we will get this nice interface through which we can interact with this contract. So right now we only have one function, and Remix is helpful enough because it provides this nice UI structure and some buttons to interact with our smart contracts. So we already got this button, get contract balance. Let's click on this button to interact with our smart contract. So when we click on this button, let's head over to this section. Let me click on it again. As we can see, there was one transaction that happened when we clicked on this button. So let's open up this transaction. You need to click on this icon over here. This is the transaction that happened when we clicked on this button. And this function returns the total contract balance. And if you observe in the decoded output, we have got this log where it says that there's zero balance because we have not added any money yet. So the initial balance is zero. That's what we got here. So now we have created our first basic smart contract and deployed it to the blockchain. Now what it means to deploy is basically, see, Ethereum is kind of a world computer, and anyone can deploy their smart contracts to this computer, and it costs some ether and real ether if you want to deploy it on the Ethereum main chain. And anyone can interact with this smart contract by calling this kind of functions, and this functions cost ether as well. So there are some functions which don't cost ether, and some functions cost ether. So right now the total contract balance is zero. So let's see how we can write a function to add money to our smart contract. Let's head over to the quest. So in the 5th subquest, we'll see how to write a function of that kind. So for this, let's open up this link, which is this one. Let me maximize. Okay, this is better now. So in this contract, we create another function called add balance, and we pass two parameters. One is user address and the amount that user will be depositing. Okay, and you will notice this payable keyword, but I will explain it later. So what this function will do is it will create a mapping. Mapping is basically kind of a dictionary if you have used Python. So it will map the address to the amount. So address will be the key and the amount will be the value, right? So in this function we have written in the first line, we add a new entry to our mapping with that user's address and the amount that he is depositing, and we'll also add that amount to the total contract balance. So let's compile this. Okay, so it has been compiled with some warnings that we can ignore. Let's go to deployment. Let's click on deploy. So every time you make changes to your smart contract, you have to redeploy it. In the later quest, we'll be learning how to create smart contracts which are upgradable, that we don't have to redeploy again and again. But for now, this is how it is. Okay, so let's try to interact with this smart contract that we just deployed. Now, to call this add balance, we'll first need a user address and amount, and we can't just pass any address, so we need this kind of address. So they have provided this sample address. Let's copy this and let's paste it over here, and for the amount let's enter 1 million. Okay, let's try to transact. Okay, so the transaction went through successfully. And there's not much information to analyze. Let's try to retrieve the total contract balance. Okay, we got the log, and as you can see, now we have got this 1 million. So we have successfully added the balance. But where did this 1 million money came from? And how do we know that the user calling this function is allowed to change the balance or associated with this address? And what if someone sends zero amount to any address, overwriting the balance of that victim? And even if the user is calling the function with their own user address and money, how do we even know that the user has that amount of money or not? And even if the money gets credited in our smart bank, how do we know that money got debited from the user's account? So as you can see, it gets quite complicated, and this is where Ethereum shines because it lets us bypass all these checks, and this is what we will see next. So let's check the code for the next subquest, in which we'll see how to add money or deposit money the Ethereum way. Let me open it up. So here's the code. So in other traditional languages, to the function, you can only pass parameters, but in Solidity, along with parameters, you can also pass money. And to pass money to a function, you have to provide this payable keyword. So what this means is this function add balance can now accept money once you provide the payable keyword. And msg.sender will have the address of the user who's calling this function, and msg.value will hold the amount of money being passed to this function. Now, Ethereum provides this message object by default, which every function calls, and Ethereum authenticates the user and it provides the address of the user in message.sender, and it also guarantees that the person who is calling this function holds that much amount of money in their account, and also the money has been deducted from their account before it get deposited in, or before it gets transferred through this call. Okay, so now if we look at the code, what we are really doing is we have this mapping that I showed you earlier, and in that mapping we store the key value pair, for which the key is the address of the sender and the value is the amount they are depositing. So that's what we store in the balances mapping, and increment the total contract balance by that much amount of value. We keep track of the balance in this balances array for that particular address, because when that user wants to withdraw the amount, we know that how much that particular address can withdraw. Okay, now let's try to compile this smart contract and add the balance. Okay, so now the contract has been compiled. Let's try to deploy it. Now let's try to add balance to our contract. For that, in the value text box, write one, and these are the different denominations. Select ether, and you can see that this add balance is of different color. It is of red color because it signifies that this function is payable. Okay, so now that we have selected one ether as value, let's click on add balance. As you can see, one ether got deducted from our account, and let's check the logs now. So if you observe the logs, instead of one ether, we have this value which is much larger than one. That is because this value is the smallest possible denomination of ether, which is way. So 1 ether equal to 10 raised to 18 way. So that's why we have this long value. So now that we have added the logic to add balance to a smart contract, let's see how we can generate interest. Now let's open up the code file for the next subquest where we'll write the logic for generating interest. So now to write the logic for generating interest, we need to store along with the amount that was deposited, we need to store the timestamp when that particular amount was deposited. But now the thing is, in Ethereum, the timestamps are tricky because when you call a function, this add balance, what really happens is this function doesn't get called immediately. These functions get uh, batched together with other function call in what is called a block. So that is what is block in a blockchain. Okay, so this transaction or these calls are basically the transaction which are batched together in a block, and this gets triggered after some time. So we can't get the actual timestamp when that function was called, but we can get the timestamp when that function was actually executed on the, or when that particular batch was executed. Right, so we can get the timestamp when that transaction was executed using this variable block.timestamp. So we pass block.timestamp into this mapping, deposit timestamps mapping for that particular address. Right, so now we have got a timestamp or the time when that particular transaction was executed along with the amount of value. So now when the user tries to get the balance, what we will do is first we'll get the principal amount from the balances mapping using that address, and we'll calculate the time elapsed we'll get the current timestamp, and we'll subtract the deposited timestamp, and that way we'll get the time elapsed, and we'll calculate the balance of that particular user using this formula, simple interest formula. Now you will observe that the formula is a bit complicated because Solidity doesn't support floats or doubles yet. So we have to use this complicated format to convert this timestamp, which we can get in seconds, to get the amount that is 0.07% per year. So this is what this does, and we are also adding +1 so that even if 0 seconds have been elapsed, we get at least some amount of interest. So now that we have added the logic for retrieving the principal amount plus interest, let's write the logic for withdraw function as well. So for withdraw function, we'll first get the msg.sender, which is basically the address of the user calling this function, and we will convert this address into payable. Now this is just for a check so that we don't send this money to just any address. So first we need to convert this address into payable. After that we'll use the get balance function that we created, and we'll pass the address of the user, and we'll get the amount of money that user can withdraw in amount to transfer. So with that address, we'll call the transfer function on that address. So this transfer function is already provided by default by Solidity. I think only when you convert this into payable, I guess. So when you convert the address into payable, you can call the transfer function, and you can pass the amount that you want to transfer, and this will transfer the amount to that user's account. And after that we can deduct that amount from the total contract balance, and we will change the balance of that particular user to reflect 0. So here we have given the functionality to withdraw the whole amount, and we can write the functionality to withdraw in parts as well. So let's try to compile this smart contract, and let's try to withdraw. Okay, so now that it has compiled, let's deploy it. So first we need to add balance. So let's do that. We will add 1 ether this time as well. Let's add the balance, and now first we'll try to fetch the balance of that user. Okay, so for that we need to pass the user address, which we can get by clicking on this button. So we deposited money using this address, so we'll retrieve the balance for that particular user only, or that address. So as you can see, we only deposited 1 ether, but we are getting some amount, which is basically the interest that we are calculating and adding to that ether. Okay, so now that we have added the balance, let's try to withdraw the balance. Let's see what happens. Let's click on withdraw, and let's check the logs, and this time we got an error and the transaction was not successful. Now why is that? Because see, when we added money to the balance, there was no balance in the contract, right? So if we check the contract balance right now, it is this much, but it was 0 initially, and when we added the balance, it increased by 1 ether, right? But now when we are calling withdraw function, what is really happening is we are retrieving the amount that the user deposited. In our case, it is 1 ether plus some amount, which is interest. So it is this total amount, and we are trying to withdraw this amount from this contract, but we only have this much amount. That means we are trying to withdraw the amount that we don't already have. So for that we need to write one more function, add money to contract, so that we have some reserve in our bank, so that we can provide, the additional amount of interest to the user. Because initially it will, if it is 0, how are we going to give the user some interest, right? So let's try to call the add money to contract function, and let's try to add, let's add 10 ethers this time. Okay, add money to contract. Okay, and now if we try to retrieve get contract balance, you can see it has increased by 11 ethers, and we can again check the balance of this particular user. It is this much amount, so it increased again because we are calculating the interest. And now if we try to withdraw that amount, it was successful because we have the reserve amount in our bank. That's it, we have created a fully functioning bank, right? We have given the functionality of adding the balance, we have given the functionality of withdrawing the balance. Now we can again add some more functionality like withdrawing in parts and so on. So that's basically it. We have done the first quest, the whole quest, building a bank with Solidity. So that was the first quest, and we have written all the logic. But if you observe this get balance, we are getting the principal amount from the user, but we are generating, it seems that we are generating this interest out of thin air. But if you know about the concept of interest, this is not really how the real banks work. In real banks, when you deposit the money in your account, the banks use that money or lend that money to other people, and they generate the interest. So they get the interest on that lended amount, and they give you the interest on your money from that, the interest that they generated, right? But right now we don't have that functionality. It seems that we are generating this interest out of thin air, right? So in the next quest, that's what we'll be creating. We'll be creating, a real interest. That was it for this quest, guys. Let me know if you liked it or not, and subscribe to my channel. And if you liked the video, please share it. Thanks for watching. I will see you in the next quest. Bye bye.